applying chemical principles, chemistry of the sun. Problem 1. Helium absorbs light at 587.6 nanometers. What is the frequency of this light? So to solve the problem, you would need the equation. Frequency equals speed of light divided by wavelength. So in step B, you would convert the wavelength into meters. So 587.6 nanometers equals 0.000005876 meters. For step C, you would divide the velocity by the wavelength. So you get 3 times 10 to the 8th divided by the wavelength, and you get 5.1055 times 10 to the 14th hertz. Question number 2. Iron atoms absorb light at a frequency of 5.688 times 10 to the 14th. What is the wavelength of this light in nanometers? So to solve it, you need the equation. Lambda equals frequency divided by speed of light. So you divide the frequency by velocity, so you get 5.688 times 10 to the 14th divided by 3 times 10 to the 8th, and you get 5.27 times 10 to the negative 7th meters. For the last step, you would have to convert that wavelength into nanometers, and you'll get 527 nanometers. For question number 3, sodium atoms are responsible for a closely spaced pair of lines in the yellow region of the sun's visible spectrum at 589 nanometers and 589.59 nanometers. Determine the energy in joules of a photon at each of these wavelengths, and also determine the difference in energy between the two photons. So you need the equation E equals hv, where E is energy, h is Planck's constant, and v is the frequency. So you would convert the wavelength into frequency for both problems. So you get 3 times 10 to the 8th divided by that wavelength, and 3 times 10 to the 8th divided by that wavelength. You get 5.0899 times 10 to the 14th, and then 5.084 times 10 to the 14th. You multiply Planck's constant by frequency, and it would be 6.62 times 10 to the negative 34th times 5.0899 times 10 to the 14th, and you get 3.3726 times 10 to the negative 19th. And for this one, you would do the same thing, but instead of that, you do multiplied by 5.0848 times 10 to the 14th, and you get 3.369 times 10 to the negative 19th. And the difference in energy is 3 times 10 to the negative 27th joules. For problem number 4, hydrogen has an absorption line at 434.1 nanometers. What is the energy in kilojoules per mole of photons with this wavelength? So step 1 would need your equation. The same equation, E equals h times v. You convert the wavelength into frequency, so 3 times 10 to the 8th divided by the frequency, and you get 6.901 times 10 to the 14th. You will multiply Planck's constant again. So, and then you would get 4.579 times 10 to the negative 19th joules. You would convert that into kilojoules per mole, and you get 4.579 times 10 to the negative 22nd power. For the final problem, what are the final and initial electronic states, N, for the hydrogen line in the polymer series labeled F in this figure right there? Okay. So to do that, you would need to find out what the wavelength is for hydrogen, and that's 486. And use the equation to find out that the initial electronic state is 4. And for all electronic states, the final electronic state is 2.